Proxima B, the exoplanet orbiting the nearest star to our solar system, has long fascinated both scientists and dreamers alike. While much of the attention has been focused on its sunlit side, the planet's dark side, perpetually shrouded in shadow, remained a mysterious unknown. However, the James Webb Space Telescope has now unveiled intriguing data that sheds light on this hidden region, revealing surprising findings that have left experts both astounded and puzzled. One side of Proxima B is constantly exposed to sunlight, while the other remains locked in unyielding darkness. Previously, it was believed that the dark side was inhospitable and barren. Yet, recent declassified images have begun to tell a story no one anticipated. The first clues emerged in the form of unusual emissions detected from the dark side of Proxima B. These faint, but consistent signals challenge conventional ideas about planetary environments. Infrared radiation and unique energy signatures point to localized sources of heat and light, phenomena that don't align with the planet's established conditions. Could these emissions be naturally occurring, or do they hint at something far more extraordinary? The strange structure and variability of these signals have prompted some scientists to entertain the possibility that they may have artificial origins. Could it be that the dark side of Proxima B is concealing advanced technological activity? If these emissions are indeed artificial, they could suggest the presence of a civilization thriving under extreme conditions. Advanced technologies might be in place, generating light and warmth to overcome the challenges posed by the planet's eternal darkness. These emissions, resembling urban lightning, imply organized activity. Could this point to a society that has adapted to and is flourishing in an environment devoid of natural light, thriving in ways that are beyond our current comprehension? The implications of these findings are enormous. If life exists on Proxima B, it might have developed technologies far more advanced than anything we can currently imagine. These technologies could enable the survival of life in one of the most extreme environments in our galaxy. Proxima B's unique characteristics, perpetual sunlight on one side and unending darkness on the other, create a planet of stark extremes. Temperatures on the dark side could drop to levels that make life as we understand it impossible without a substantial atmosphere to distribute heat. Any form of habitation would likely rely on artificial energy sources. Could a civilization on the dark side have solved this problem by developing systems to transport heat and power into the shadowed areas? Achieving such a feat would require engineering expertise far beyond anything we have on Earth, offering valuable insights into how advanced life might function. One of the most remarkable findings was the potential presence of water on Proxima B's dark side. While liquid water on the surface may be improbable, there could be subsurface reservoirs sheltered from the harsh surface environment. Water is essential for life as we know it, so if it exists here, it suggests the possibility of extremophiles, life forms that thrive in the most hostile conditions. The discovery of water would not only expand our understanding of habitability, but could also provide a glimpse into how life might adapt to survive in one of the universe's harshest environments. Despite the groundbreaking nature of these revelations, the data raises more questions than it answers. What is the source of these mysterious emissions? Are they the result of natural processes, or do they indicate something far more significant? The recurring patterns of these emissions imply intentionality, yet no known natural process fully accounts for them. Could we be witnessing the effects of an advanced civilization, or is this a manifestation of some unknown cosmic phenomenon? As researchers continue to analyze the data, one thing is clear. The dark side of Proxima B is not the lifeless void we once thought it to be. Instead, it is a place brimming with mystery, potential, and unprecedented discoveries. The emissions detected from Proxima B's dark side prompt an intriguing question. What is powering them? In an environment devoid of sunlight, traditional sources of heat, such as solar power, seem unlikely explanations. One theory proposes that the planet's core could be geologically active, generating geothermal energy. This heat might sustain subsurface water reservoirs and power systems on the dark side. Another theory points to the possibility of nuclear energy, an energy source capable of generating immense power in isolated, lightless conditions. If the emissions are artificial, they could represent the work of a civilization that has mastered these forms of energy generation. Whether the emissions are natural or artificial, the energy source behind them could radically alter our understanding of power generation in extreme environments. Further analysis of Proxima B's dark side revealed unexpected patterns in its thin atmosphere, or what's left of it. Trace amounts of gases, including carbon dioxide and methane, were detected, raising questions about their origins. These gases could be the result of geological activity or even biological processes. The detection of methane, in particular, has sparked debates among scientists, with some considering the possibility that it could be a byproduct of microbial life, or even something entirely unknown. The uneven distribution of these gases suggests localized sources, possibly linked to the mysterious emissions. Could this be a clue pointing to active processes or even life on Proxima B's dark side? Proxima B is just one of many exoplanets observed by the James Webb Space Telescope, yet its dark side stands out as a particularly enigmatic case. By comparing it to other tidally locked worlds, scientists hope to identify patterns that might explain its unusual characteristics. While most tidally locked planets exhibit extreme temperature gradients, the emissions and atmospheric anomalies observed on Proxima B's dark side make it an outlier. These findings suggest that Proxima B may harbor processes unlike any we've observed elsewhere in the universe. As we learn more about Proxima B, our assumptions about exoplanets and their potential for habitability are being challenged. One of the most contentious theories surrounding the dark side of Proxima B is the possibility of advanced technology. The structured patterns of the emissions, coupled with the energy demands required to sustain them, strongly imply the involvement of intelligent forces. Could these emissions be the product of an extraterrestrial civilization? If so, their technology would be far beyond anything humanity has ever conceived, capable of thriving in an environment of perpetual darkness. While this hypothesis remains speculative, it raises profound questions about how life and technology could evolve under conditions drastically different from our own. The discoveries from Proxima B's dark side have reignited interest in interstellar exploration. Although sending a spacecraft to the planet would be a monumental challenge, the potential rewards make it worth pursuing. Organizations like Breakthrough Initiatives are already investigating ways to reach Proxima Centauri within a human lifetime. The data collected by the James Webb Space Telescope provides a roadmap for future missions that will focus on Proxima B's dark side. These missions could help answer the many questions left by Webb's observations, from the source of the emissions to the nature of the structures hidden in the planet's darkness. Proxima B's dark side is more than just a scientific enigma. It is a mirror reflecting our own questions about existence and survival. If life can thrive under such extreme conditions, what does that say about the resilience of life across the cosmos? The possibility of technology or even life on Proxima B challenges us to rethink our assumptions about what is possible. It sparks curiosity, offers hope, and perhaps even a touch of fear, as it reminds us of the vastness of what we have yet to learn about the universe. As we study the dark side of Proxima B, we are reminded that exploration is not only about answering questions but also about asking new ones that push the limits of our understanding. The James Webb Space Telescope has once again proven its unparalleled ability to uncover the unknown, shedding light, ironically, on the mysteries hidden in perpetual darkness. Proxima B's dark side, once thought to be a barren wasteland, now presents questions that challenge our understanding of the universe. Are these findings evidence of natural phenomena, or do they suggest the presence of something far more extraordinary? A civilization thriving in conditions we can barely imagine. While the answers remain elusive, the possibilities are staggering. The data from Proxima B's dark side has inspired both scientists and dreamers, expanding the boundaries of what we know about habitability, technology, and the resilience of life. It reminds us that, even in the vast emptiness of space, there are still surprises waiting to be uncovered. Exploration is not just about seeking answers. It's about igniting curiosity and uniting humanity in the pursuit of the unknown. Proxima B's dark side stands as a beacon for the next generation of explorers, a reminder that the universe still holds secrets that could revolutionize our understanding of existence. This discovery challenges our perceptions and encourages us to think beyond traditional limits of habitability. The idea that life could thrive in such a harsh, seemingly inhospitable environment calls into question many of our long-held assumptions about the requirements for life to exist. Proxima B's dark side has become a focal point for exploring the unexpected possibilities that the universe may offer. The unexpected emissions and potential for water and energy sources have raised more than a few eyebrows, pushing the scientific community to expand the scope of its search for life beyond Earth. As we look deeper into Proxima B, we are faced with new and evolving theories. Could the emissions be signs of something we've never imagined? If a civilization exists there, it might be capable of surviving in the total absence of light, using technologies so advanced that they remain undetectable by our current methods of observation. The way these emissions are organized, their consistent nature, and the heat signatures they emit, these are not random occurrences. They suggest intelligent design or, at the very least, active processes that we are still trying to understand. If this is indeed evidence of an advanced civilization, it could represent a significant breakthrough in our understanding of alien life forms and technology. Imagine a species capable of surviving under perpetual darkness, with technologies that manipulate energy sources in ways we can only dream of. This could radically change our concepts of life, survival, and the potential for intelligent life elsewhere in the universe. These findings, though preliminary, offer a glimpse into a reality that may be far stranger and more complex than anything we could have imagined. Furthermore, Proxima B's status as a tidally locked planet makes it an even more captivating subject of study. The fact that one side is constantly bathed in light while the other remains perpetually dark creates a dramatic contrast that raises important questions about the planet's climate, atmospheric conditions, and possible biospheres. It's possible that, despite the extreme differences between the two sides, there could be an ecosystem or habitat thriving in ways we can't fully comprehend. The presence of emissions and potential water sources might be indicative of life or technological solutions that bypass the extreme challenges posed by the planet's unique conditions. The potential for life on Proxima B, or for technological activity, brings us back to the heart of exploration itself, the unknown. Whether these emissions are biological, geological, or the result of artificial technology, they force us to consider new possibilities. Could Proxima B harbor forms of life or intelligence that don't rely on the same biological processes we recognize on Earth? Could the key to understanding life in the universe lie in these strange emissions, pointing toward life forms with completely alien biologies and technological capabilities? At the same time, the search for answers isn't just about the exploration of Proxima B itself. It is also about the broader implications of these discoveries. By studying this exoplanet and its unusual features, we can gain insights into the potential conditions for life elsewhere in the universe. Could similar conditions exist on other planets orbiting different stars? What if Proxima B is just the first of many worlds where life adapts in unique and unexpected ways? The possibilities are endless, and this makes it all the more crucial to continue studying the planet, gathering data, and refining our understanding. The importance of future missions to Proxima B cannot be overstated. With the James Webb Space Telescope paving the way, we now have the tools and the knowledge to look deeper into this mysterious exoplanet. Future missions, potentially launched by both government space agencies and private ventures, could offer us the answers to some of the most pressing questions. Is Proxima B home to life? Are the emissions a sign of intelligent life? Can we learn from this planet's extreme environment and adapt some of those lessons to our own survival challenges here on Earth? This journey of discovery is far from over. Each new piece of data we uncover only deepens the mystery, but it also drives humanity to ask more questions. It pushes the boundaries of what we think is possible and challenges our assumptions about how life can exist beyond our home planet. As we venture further into space and explore these alien worlds, we are not just looking for signs of life. We are looking for new perspectives on what it means to exist in the cosmos.